Okay. Let me go get the test, and I'll tell you what to look for.
The one time I had two, and it took me 4 hours to work it. We had a fourth-order differential equation, of course, it took it 2 lines. And the answer was a sub 0, left parenthesis 1 minus x over 2 right parenthesis. Plugged it in, you can check your work in a minute, but it took 4 hours to get that miserable answer. That was awful. One little mistake when you're doing the series. Oh, it's awful.
S3 has, first problem says, find a Taylor series approximation of order 4 for the given function. I give you a function and you write a Taylor series for it. Problem 2 is a series solution for a differential equation, and write out the series through n equal 4. It's a very easy series, very much like that example that I worked. All you have to do is just walk through it. That's 2. 3 is a linear differential equation. 4 is a linear differential equation. And 5 and 6 are find the radius, or I'm sorry, the interval of convergence of the power series. I give you the power series with the nth term already spelled out for you, right? And what do you do with it? How do you find the interval of convergence?
You use the ratio test?
What?
Is that the one where you use the ratio test?
It is indeed the one. You use the ratio test, and you work out the ratio test, and only after you take the limit, the last step of the ratio test is take the limit as n approaches infinity, right? You will have something with x still in it. Do you remember that? And it'll be the absolute value of x will equal some number. No, the absolute, you'll have some function and you'll say that it has to be less than 1, doesn't it? Because that's when the ratio test converges, huh? Then you'll solve for the absolute value of x, and you'll get some number, right? But the absolute value, if I have the absolute value of x, the absolute value of x less than 3, you remember that is x less than 3 and greater than minus 3, and that is the interval of convergence. And we did several problems on them, right? And if you remember, what makes them hard is after you've done a series, then you have to find the nth term of that series, right? But you don't have to do that here because I'm giving you the nth term. Follow? So all you have to do is use the ratio test and find what values of x make the ratio be less than 1, which is where it converges. And you got problems in the notes like that, don't you? Okay? That's it. That's it. 4 and 5. So I have 2 linear problems. I have you create one series, and I have you solve one series with a power series. I'm going to put a 6th problem on it that is a second Taylor series. That way I can give you one that has e to the x, find the Taylor series for e to the x, or one find the Taylor series for sine x or cosine x, or one that has 1 over x or something like that. It'll be stuff you've seen. By now you know my tests are stuff you've seen. I promise you the differential equation that's on there, there are 3 differential equations. 2 you do linearly, 1 you will do by a series. Aren't going to be much different than what you saw in class today. Questions? Anybody? Okay, that's it. And then on Wednesday, I'll ask if you've worked any of the homework problems and have a question. I'll work them for you in class. If you'll tell me, if it's homework, print it off, and we'll work it together. Or if it is out of the book, work those practice problems out of the book. That's what the test looks like. Questions? Everybody? Okay. See you Wednesday.